exponentials and logarithmic equations. So we're going to look at how do we solve equations using exponentials and logs. So we have a rule. It's called the power of the same base. So the power of the same base rule says if we have b to the m and it's equal to b to the n, then we can say that m is equal to n. So basically, if they have the same base, the bases kind of like cancel out, and we can set the powers equal to the powers. So let's do an example of what this could look like. Let's say we have 2 to the 2x plus 3 equals 2 to the 10. So see how the bases are equal? They both have a base of 2. So we can say, okay, the bases are equal, so they're going to like cancel. We can set the exponents equal. So then we can say, okay, well, then 2x plus 3 equals 10. And then from there, we could just do algebra and solve, and we get that x is 3.5. All right, let's look at one that's not so obvious. The bases are equal. So let's say we have 5 to the 3x minus 6 equals 125. So when you first look at this, you can see the bases are not equal because one's side and one's 25. But we can actually make the bases equal in this one because we can rewrite 25 with the base of 5. I'm sorry, 125 with the base of 5, because we should know that 5 to the third power is equal to 125. So I can rewrite this as 5 to the 3x minus 6 equals 5 to the third power, because 5 to the third power is 125. Now look, the bases are equal. Since the bases are equal, we can set the exponents equal. Add 6, 3x is 9, divide by 3, and x equals 3. So our solution for that would be x equals 3. Okay, let's look at another one. So let's say that we have 8 to the x plus 2 equals 4 to the x minus 3. So again, our exponents are not equal, but we can make them equal because we can rewrite 8 and 4 both as like a base of 2. Because like 2 squared is 4 and 2 to the third power is 8. So I'm going to rewrite them as that. So we're going to rewrite 8. So let me write it to the side so you can kind of see what I'm talking about. 2 to the third is equal to 8. And 2 squared is equal to 4. So like we can rewrite them both as like a base 4, basically. So this would be 2 to the third times that x plus 2 equals 2 squared times that x minus 3. So now they have the same bases. So the bases like cancel, and we can set these equal to each other. Sorry if you hear my pen clicking and clicking on the screen, and try to like be more quiet with it. We distribute and we get 3x plus 6 equals 2x minus 6. And then we'll just do algebra and solve. So I'm going to subtract the 2x. And x equals negative 12. And there we have our answer. Okay, so now we're going to look at how can we use logs to solve exponential equations when we can't like write them as the same base. So I'm going to go on to the next page. So using logs to solve equations. So let's say we have 5 to the x equals 134. Well, I can't write these with the same base because like 134, like I can't rewrite it with a base of 5 or anything like that. So we're going to take a couple different steps and we're going to solve it and get like an approximate answer using logs. So we want to first step is to isolate the exponential expression. which in this case it's already isolated. That's talking about the like 5 to the x. We want to make sure that's isolated. So if we would have had like 5 to the x plus 1 equals 134 or something like that, you would want to move the 1 over first. So that's the first step, isolate the exponential. Second, we're going to take the common log of both sides, or the natural log. So take common log or natural log. So either one. And so we want to take the common log of both sides if like we have a base 10. And then if we don't have a base 10, so like if this was 10 to the x equals 134, see how like that's a base 10, then we would take the common, or the log, the common log. And then when you don't have a base 10, we can just take the natural log of both sides. So if the base is not 10, take the natural log. If the base is 10, take the log. So we want to use this if we have a base 10. And we want to use this for all other bases. So I'm going to take the natural log of both sides. So the natural log of 5 to the x is equal to the natural log of 134. Okay, and so then we can use our properties that we learned last week. So like, let me see, step 3. Simplify using properties from not last week, but Tuesday. So like in this case, I can use the power rule to bring the x to the front. So then I'll have x times the natural log of 5 equals the natural log of 134. And then from there, now we can solve for x by dividing both sides by the natural log of 5. So x is equal to the natural log of 134 over the natural log of 5. And then from there, you can just type that into your calculator, divide it out, and you'll get that x is approximately 3.04. And like when you're doing your homework, if it wants an exact answer, then you could type this in. And if it like tells you like an estimate, you could type this in. But I'm pretty sure it's probably going to want an exact answer. And that L, make sure you type an L because some people were struggling with that because they thought it was like a 1 or I don't even know, an I or something. So make sure you use the lowercase L for natural log when you're doing your homework. Let's do another one. So we're going to solve 10 to the x equals 8,000. So you can see this one has a base 10. So first step, isolate the exponential, which is isolated to the x is by itself. Second step is take the log or the natural log. Since we have a base 10, on this one we're going to take the common log. So we'll take log base 10 to the x equals log of 8,000. And then from there, we can do the power rule. We could do the power rule, or since like remember the log of 10 is 10. So yeah, we don't have to do the power rule. Since the log, remember the base of the common log is 10, those are going to cancel. And it's just going to leave you with x equals log of 8,000. And if you type log of 8,000 into your calculator, you will get approximately 3.9. So again, your homework will probably want an exact answer, so we'll probably want that one. Okay, let's look at another one. Probably have room over here for another one. Let's look at 3 to the 2x minus 1 equals 7 to the x plus 1. So on this one, we have exponentials on both sides, which is just fine. We're going to start by taking the natural log of both sides. Natural log because our base is not 10. So natural log of 3 to the 2x minus 1 equals the natural log of 7 to the x plus 1. And so then we'll use our rules to simplify. So we're going to do the power rule. So using the power rule, we'll bring that power to the front. Okay, so we're going to bring that 2x minus 1 times the natural log of 3 equals x plus 1 times the natural log of 7. And then what we're going to do is we're going to distribute the natural logs in. So to like get it in like simplest form and things like that, we are going to do, let me change colors. We're going to distribute the natural log in. So we'll get 2 x times the natural log of 3 minus 1 times the natural log of 3 equals, distribute this also, x times the natural log of 7 plus the natural log of 7. Okay, now again, remember that we're trying to isolate the x. So I'm going to put the terms that have x's all on the same side and the terms that don't have x's on the same side. So see how this one has an x and this one has an x? So I'm going to move this one this way and move this one this way, basically to get all the x's on the same side. So if I move those over, I'm going to end up with 2x natural log of 3 minus x natural log of 7, because I moved that over, equals, and then I'm moving the natural log 3 to the other side, so it'll be a positive natural log 3 plus natural log 7. Now we can isolate the x. I can say that the x is like a GCF basically and like factor it out. So we're going to factor out the x out here, and I'm left with 2 natural log 3 minus natural log 7 equals natural log 3 plus natural log 7. And now I can just divide to get the x by itself. So we'll divide both sides by this. And so we get that x is equal to the natural log of 3 plus the natural log of 7 over 2 times the natural log of 3 minus the natural log of 7. And that L kind of looks like an E, but that's an L for natural log. And so if you type that into your calculator, that is approximately 12.11. Or you can leave it in exact form for your homework. Okay, let's move on. Next section is talking about using logs to solve logarithmic equations. So we're going to look at things that look like this, like they have a base and then something and then it's equal to c. And so remember that that's logarithmic form, and we can change those to exponential form. So remember, we can always change that to b to the c equals m. And then we'll just solve for the variable and all that. Now for these, it's important, we always want to check our solutions. So for equations that look like this, after you get your answers, you want to check solutions, because you only want to include solutions for which, only include solutions for which m is greater than 0. And so you'll see what I mean here in a minute when we start plugging some of these things in. Okay, so let's say we want to solve log base 2 of x minus 4 equals 3. So this is in logarithmic form. We want to change it to exponential form using the rule above, using this rule. So we can rewrite it as 2 to the third power equals x minus 4. And so now it looks like a problem that we can solve easier, because we know 2 to the third power is 8. And then from there, I'll add 4, and I get that x equals 12. Okay, so once you get that answer, what you want to do is you want to take this answer and you want to plug it in to this and make sure that it gets you a positive number, because you don't want to take the log of a negative number, basically. Or we'll check it to see if it's like accurate and things like that. So if we plug in 12, we get log base 2 of 12 minus 4. 12 minus 4 is 8. And this ends up being true because we can rewrite the 8 as a 2 to the third power, and then those cancel, and we get that 3 equals 3. So our answer checks out. Let's do another one. We want to solve 4 times the natural log of 3x equals 8. So let's start by isolating the natural log. So we can divide by 4 to simplify it a little bit. And we're going to get the natural log of 3x is equal to 2. Okay. So then remember that the natural log has a base of e. So we can rewrite this exponential form into, this logarithmic form into an exponential form. So just like we rewrote the other one, we can say e squared equals 3 to the x. And then we can solve for x by just dividing by 3. And we get that x equals e squared over 3. And you could plug that into the original equation. So I'll plug it in for you to check. So it would be 4 times the natural log of 3 times e squared over 3 equals 8. And so when you're solving that out, the 3's cancel. And you get 4 times the natural log of e squared equals 8. Since that's a base e, those cancel, and you just end up with 4 times 2 equals 8, which is true. And we have a couple more to do.